Can you see the screen?
Yes, sir.
Okay, fine. So let us start with amines. Now, in amines, since you have started, you must already know that what are the different. So first of all, let me talk about the whole chapter. So you have amines chapter, and in this chapter you will have a few things. There will be structure. Okay, we'll be talking about structure of amines, right? And then you have classification 1 degree, 2 degree, correct? Classification is there, right? Then you have here only you can add that nomenclature is also there. Nomenclature. Then amines you will have physical properties. In physical properties, what do we do? Physical properties. Mainly it is about boiling point and melting points of amine, right? Boiling points and melting points. Now comes the two major area, that is the preparation of amines and then the chemical reactions and chemical properties. So let me write the preparation here. Preparation of amines, right? In preparation, you have many different subcategories, or you can say reactions that are present for the preparation.
Sir.
Yeah. Sorry. I was adjusting my
chemistry chapters, like if question is coming like convert this to this, in that only we have to write the reaction or we have to explain the steps. This is reacted to this.
No, you don't have to write any statement. For example, they're writing how to convert A to B.
Yes.
Right. Then A to B, then you will just write A, it gets converted to, let us say, D, then it converts it, let's get converted to C, and then it converts to B. This is the reagent 1, this is the reagent 2, this is the reagent 3. That's it. बस इतना ही लिखना आपको, nothing else. Okay, not a word. Okay.
Okay.
The only words you have to write is when you are given, for example, they are asking about, let us say, what is aldol condensation. Then you will write the reaction and then you will just write in words also and then give one example. Okay, so सबसे पहले you will write in terms of R. Okay, you have general reaction like this. Okay, when aldehyde reacts with so and so, it gives the product so and so, and then you will write an example, specific example using some number of carbon molecules. Okay, for example, you will use benzaldehyde or something. Now, preparation of amines, you have various reaction in preparation of amines. You can do preparation of amines with reduction of RNO2 nitro compounds, right? Then you can do ammonolysis of alkyl halide, ammonolysis of alkyl halide. Alkyl halide is RX, right? Then what else you can do? You can also reduce nitrites, reduction of nitrites, right? Furthermore, what you can do? You can do amides reduction of amides. What else can you do here? There's one name reaction. No? There's one name reaction. One is HV, Hoffman bromamide degradation, right? Hoffman bromamide degradation. Okay. Then there is Gabriel Thalamide synthesis. Gabriel Thalamide synthesis. Okay, Gabriel Thalamide synthesis. Then you have one more thing. HVZ to छोड़ दीजिए उसको. So you have to Gabriel Thalamide synthesis. Then there is chemical reactions. Okay, so you have chemical reactions. Now in chemical reactions, the first chemical reaction will be about the basic character, right? Basic character of amines. Now this is due to the lone pair in. This is due to the lone pair here, right? Basic character. Then you have alkylation or acylation of alkylation. Acylation right? Next, you have Carbylamine reaction. This is an important reaction. Carbylamine reaction. Okay. Then you have reaction with nitrous acid. Reaction with nitrous acid. What is nitrous acid? Oh no. You remember oh no?
Yes.
Nitrous acid. Okay. Oh no. Then you have a reaction with aryl sulfonyl chloride. Aryl sulfonyl chloride. Okay. Then last you have the electrophilic substitution reaction of benzene. Electrophilic aromatic substitution of anilines. Okay, benzene in which you have NH2 group attached. Is that clear? So see, in this, you have to learn a few things, right? The structure, classification, nomenclature. Okay. So for this, what I will do, previous year questions. Okay. Then you will do some things about physical properties. After that, preparation of amines. How to remember for preparation? You just have to remember the substrate. Why? Substrate and reagent. And if you remember the substrate and reagent, you already know the product. What is the product here? The product will be always amine because we are preparing amine. So no brainer. Okay, there is no brainer question here. You have to just remember two things: substrate and reagent. The product will always be amine. The product will always be amine. Now, when you have to remember the chemical reactions, so in chemical reaction, what do you have to remember? You have to remember the reagent and product. Okay, the reagent and product. See, sometimes what happens, reagent is already given. For example, here nitrous acid, reaction with nitrous acid, right? Reaction with aryl sulfonyl chloride. And here the reagent has already been given. So most of the time you just have to remember the product and what are the products formed in alkylation, carbylamine reaction, reaction with nitrous acid, and reaction with aryl sulfonyl chloride, and electrophilic aromatic substitution of aniline. Okay, now let us see. I mean, so you don't have to write anything. Okay, just listen and do the questions. Just listen and do the question. Also, one more thing, you have the amines note, na? Like the classes that we took of amines, yes or no?
Yes, sir.
So keep
Yes.
that with you. Keep that with you. Okay, refer through that, and after that we can do some questions. So let us start with IUPAC nomenclature. For IUPAC nomenclature, let me just write this here that you have NH3. This is ammonia. Okay, this is ammonia, and then you will have RNH2. What is this? This is 1 degree amine. Then you have R, N, R, and then you have H. This is 2 degree. Then you have R, N, R, and then is one more R. This is 3 degree amine. Okay. Now, IUPAC nomenclature. How do we IUPAC nomenclature do the IUPAC nomenclature? See, let us take this one example. CS3, easy example. CH2, NH2. Okay. So in this case, first of all, the first thing that if you have a very simple thing, then you will just name it as alkane amine. Okay, alkane amine. So this is what ethane amine.
Ethane amine.
Okay. No. If you have something like this, CS3, CH, CS3, and then the NH2 group is here, then it will be what? This is propane 2 amine. Okay. So basically it is R, NH2, and it is alkane amine. Okay, RNH2, that is alkane amine. If you have simple nomenclature here. Okay. Now let us see some questions that were asked. The question asks you questions in which you have the nitro group, the N nitrogen, which is having more than one alkyl groups attached to it. So it is CH2, CS3. Then you have a CS3 group here, and you have a CS3 group here. Now in this case, you will have to choose the primary chain, the main chain. The main chain is the longest one, so you'll choose this one as the main chain. Okay, so this is what? This is your main chain. Main chain is CH2. Now there is a nitro group there, so that will be obviously an amine. And this nitro group has what attached? A CH3 group here and a CH3 group here. Okay, so see, how are you going to name this? You have this ethane amine. Okay, this is ethane amine. Here you have the functional group, this amine, right? And then you have the unsat. It is AN, and the parent, it is H, right? It is H. And then let us talk about the substituent. Substituent is dimethyl. It is dimethyl. And dimethyl, it is attached in which carbon? It is not attached in any of the carbons. So how do we number it? We number it by putting N and N. That means both the methyl group is present at which position? At the nitrogen. So we'll write it like this: N comma N. Then there will be a dash because it is just acting as a number. It is not a number, but still we are using N dash, N dimethyl. N dimethyl ethanamine. N dimethyl ethanamine. Okay, so this was out in 2017. Is that clear, yes or no? Yes, Abir?
Yes, sir.
Is that clear?
Yes, sir.
Okay.
So this
Right,
question came in 2017?
Yeah.
Okay. So if the question comes only, we can write the name, right? This is not needed, right? Functional group. This we have to write in exams. So
You just need to write this thing. You just need to write this thing.
Okay, sir.
Okay.
Yes.
Next question. Try this one, okay? CH3, CH2, nitrogen, CH2, CH3, and CH3. See what happens when I do this thing now at functional groups and saturation, parent, and substituent. It makes it easy, right? So you will tell me what is the functional group here. As you can see, there is nitrogen, so it will be amine. Okay, because this 3-degree amine, you can see that it is 3-degree amine. Then tell me the unsaturation.
N.
AN, EN, or YN?
AN.
AN, very good. This AN. Parent. Parent will be what?
So
Now you have Eth, right? It will be Eth. So you are choosing one of this. Let us say that this is chosen parent. Okay. That means we have now substituent. Let us write about substituent. So anything that is remaining after the identification of functional group, unsaturation, and parent is known as the substituent. So you have the two substituent here. This is ethyl and this is methyl. So you have ethyl and you have methyl, right? And ethyl is in which position? It is in N position. Methyl is also in N position. So the name will be, now you have to keep in mind when you're writing the substituent, then you have to keep in mind the alphabetical order. So Eth, the E comes first. That is why it will be N ethyl. Then there will be N methyl, N ethyl, N methyl, ethanamine. Ethanamine. Okay, is that clear, yes or no?
Yes, sir.
No, right, next question. CH2, there is a double bond. There is then CH, single bond, CH2, NH2. Okay, now this was asked in 2013. Now, you tell me here, what is the functional group? It is amine, right?
Amine.
Anna. Unsaturation, is there any unsaturation?
Yes, sir. En.
En, very good. And the parent will be 3 carbons?
Prop,
right? Is there any substituent? There is no substituent.
No, sir.
There is no substituent, no? Hello? Is there any substituent?
No, no substituent.
No, sir. Now numbering. Now, should I do 1, 2, 3, or should I do 1, 2, 3? Tell me. Which one should I do?
Sir,
Black or
yellow?
Yellow color. Very good. Very good. So this will be one. Amine is in the first position and En is in the second position. So you see how easy it is. You have prop. After that, we'll write 2 En, right? And then we'll write 1 amine. Or you can also write prop 2 N amine, right? So if you don't write any number for amine, it will be supposed that it is in the first position. Okay.
Yes.
The other thing that usually people don't focus on more is how to write the structure from the name. So you have N-methyl. You have N-methyl ethanamine. N-methyl ethanamine. Okay. So whenever you are writing from name to structure, then first thing is the parent you will write. Okay. You will identify the parent and you will draw the parent. So our parent is eth. Okay. So I'll write CH3, CH2. And there is amine group. So CH2 will have amine group here. Okay. And it is saying N-methyl. So it is a 2-degree amine. So there will be NH and there will be a CH3 group here like this. Is that clear?
Yes, sir.
Okay. Now these two questions, both these two, like the first question and the second question, these were both asked in 2013. Okay, right, next. So these are easy, right? These are easy questions. Nothing difficult here. NH2, CH2, CH2, CH double bond, CH2. Okay. Now you have to name it. So again, it is very simple. Functional group is amine. Unsaturation is En 1, 2, 3, 4. It is but. There is no substituent. Now let us number it. So it will be numbered from here. We will give priority to the functional group. So 1, 2, 3, and 4. So you have amine in the first position and En is in the third position. So it will be but 3N 1 amine. Okay. This was in 2010. Can I move?
Yes, sir.
Let us see some question. In this, you were asked the pure, it was amine, right? So now let us see if you have something mixed. So write one question. Write one question which was in 2014. This question was like this. You have NH2 group here. Okay. And then you have OH group here. Okay. So in this case, tell me what is the functional group? What is the functional group here?
Amine.
हाइड्रोक्सी ना देखिए OH है. प्रायोरिटी याद रखिएगा, अमीन नहीं है. ठीक है. You have to remember the priority. Do you remember the priority order?
No, sir.
नहीं तो वो तो याद करना पड़ेगा ना, बिना उसके कैसे होगा नॉमेनक्लेचर. आप इतना भी कर लीजिए नॉमेनक्लेचर. प्रायोरिटी ऑर्डर अगर आपको नहीं याद है, इवन इफ यू डू 100 क्वेश्चन, तभी आपको प्रायोरिटी ऑर्डर तो नहीं याद होगा. बस क्या होगा 100 सवाल करने में, अच्छा ओहो यहाँ पे ये होगा, अच्छा ठीक है. फिर 5 सवाल ठीक होंगे आपके, है ना. फिर छठा सवाल में ओहो अच्छा ठीक है एल्डिहाइड का ज्यादा होता है प्रायोरिटी कीटोन से. ओके ठीक है, अब याद होंगे. फिर 5 सवाल होंगे. फिर आप जो पहले जब फर्स्ट क्वेश्चन में गलती किया था ना, वो आपको भूल जाएगा. तो प्रायोरिटी ऑर्डर को याद करके रखिए. ठीक है. You will get the priority order anywhere in NCERT of 11th standard, है ना. Or else if you have that, you remember I sent you one link ना, YouTube video. अबीर.
Yes, sir.
उसमें है ना हमने एक सेक्शन है जिसमें फंक्शनल ग्रुप से सिर्फ डील किया है हमने, है ना. Yes or no?
Sir,
There is one video ना.
I did not see.
हाँ?
That video I did not saw. Maybe.
नहीं उसको देखिए. ठीक है ना. एंड इन दैट यू हैव सम प्रैक्टिस क्वेश्चंस आल्सो. उससे प्रैक्टिस कीजिएगा उसको. ठीक है. प्लीज रिमेंबर दैट ऑर्डर. ओके. नाउ इन जनरल हम बता दे रहे हैं आपको. इन जनरल लाइक हाउ आई रिमेंबर्ड इन माय 11th स्टैंडर्ड, जब ये चीज बहुत नया था. आई सॉ दैट इफ यू हैव कार्बन डबल बॉन्ड ना, ऑक्सीजन ऐसा कहीं पे भी है, तो इट हैज टू बी सीन फर्स्ट. अगर आपके पास ऐसा कुछ सवाल होता है जो कि आया भी था, इफ यू हैव अ क्वेश्चन लाइक दिस CHO, ठीक है, और मान लीजिए यहाँ पे NH2 लगा हुआ है, तो यहाँ पे I know that here there is a double bond, so obviously this will be a higher priority, okay, than the single bond here. इसको बस याद रखना था हमको. C double bond O अगर कहीं पे होगा तो उसका higher priority है, because we have carboxylic acid, then we have ester, then we have amide, all of them are having what? C double bond O. ठीक है. और उसके बाद OH और NH2 में OH का ज्यादा है, आपको याद ही हो गया. देखिए COOH हो गया. ठीक है. एंड देन यू हैव SO3H जो कि उतना यूज नहीं होता है. देन व्हाट डू यू हैव? यू हैव esters, right? COOR. then you have oil halide, that is COCl, that is also not used very much. Okay, then you have amide, CONH2. Okay, after that, what do you have? Tell me. After that, there is nitriles. Okay, you have C triple bond N. Then you have aldehyde, CHO. Then you have ketone. Ketone is CO. Then you have OH, and then you have NH2. ठीक है, तो इसको अच्छे से किसी किताब में उसको वीडियो देखिएगा, साथ साथ प्रैक्टिस कीजिए, 10 बार लिखने से भी कुछ नहीं होगा मेरे. ठीक है, practice it, then only it will be there. Functional group का वीडियो देखिए. Functional group is OL. Functional group is what? It is OL. Then you have unsaturation. Unsaturation is what? AN. Then you have parent. A parent, as you can see, I have 1 carbon, 1, 2, 3, and 4 carbons. So this will be bute. And then we have substituent. Substituent is amino. ठीक है, तो इसका नाम चेंज हो जाता है, अमीनो हो जाता है ना when it is a substituent. Now let us see what number should I give. It will be 1, this will be 2, because functional groups start करते हैं 3 and 4. So amine is in the second position and OL is in the first position, so I can write it as 2 amino butane 1 ol. Okay, butane 1 ol. Is that clear? Yes or no? Please tell me.
Yes, sir.
ठीक है, सिमिलरली जो सवाल अभी हमने दिया था उसको कीजिए आप. 1 2 3 4 CHO NH2. ठीक है, तो यहाँ पे आपके पास this is aldehyde, so it will be Al. Then unsaturation is An. Okay, and then you have the parent. So parent is again 1 2 3 and 4. Parent is again 4. It will be bute. Then the substituent is amino. Okay, amino is again in the 1 2 3rd position, right? This is first, second, third position. So this is 3 amino butanol or 3 amino butane 1 al. चलिए, now let us look at some of the aniline ones. Okay,
Yes, sir.
सबसे पहले तो aniline क्या होता है? This is aniline. This is aniline. Okay, this is aniline. Then if you have, let us say, some substituent here, NH2, यहाँ पे आपके लिए मान लीजिए है Cl. This is P chloro, है ना? What we will write? P. पैरा है, so we can write P, or what we can write? We can also write 4 chloro. ठीक है, दोनों ऑप्शन है आपके पास. So जो भी, first of all, you have to see what is the benzene substituent. So this is aniline. This whole thing is aniline. So यहाँ से carbon number 1 है, 2 है, 3 है, and 4 है. Okay, so first identify it is aniline. So now this will be what? This will be 4 chloro aniline. But ये याद रखिएगा, if you have something like this, NH2 and there is OH, so it is preferred that you identify this as NH2 और OH में कौन सा था priority? OH का. So this will be named as, this is whole thing is phenol. So this will be 4, sorry, this will be 4 amino phenol. Okay, priorities में याद रखिएगा. Similarly, if you have NH2 and let us say you have CH3, so now what you can write? You can write this as toluene. This is going to be toluene. Okay, this is toluene, and you have amino in the second carbon. So this is 2 amino toluene. Also, what else you can have? You can have a NH2 group. Rather, there is a nitrogen here and there is CH3 here. There is CH3 here. So if you have this type of compound, then it will be named as N, N dimethyl, N, N dimethyl aniline. Okay. or rather not aniline because it is not NH2. Wait a second. This will be N comma N. This will be benzenamine. 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 Okay, it will be named like this. Can I move? Yes or no?
So 1 second.
Wait. Okay. Next is method of preparation. Methods of preparation. Chale?
Yes, sir.
Okay. So method of preparation. First of all, let us see reduction of nitro compounds. Okay. Number one is reduction of nitro compounds. ठीक है. अच्छा देखिए. These things are easy. Okay. Reduction of nitro compounds. एक बात बताइए अभी. What will be the product if I reduce the nitro compound? क्या product मिलेगा हमको?
Amine.
Very good. है ना? So you have RNO2. ये आपको नाम से पता चल रहा है. Then you have something here and you will get RNH2. Is that right? Yes or no? सही है?
Yes, sir.
Now this is, there will be some reagent R here, right? So R can be, R में आप क्या क्या use कर सकते हैं? R you can use as H2 and there can be some catalyst. है ना? This catalyst can be PD or PT or nickel. ठीक है? PD, PT, nickel. You have hydrogen and these are catalyst H2 over palladium, platinum or nickel. And next what you can use HCl, any metal plus HCl. Okay, there will be metal and these metal can be what? SN or Fe. Okay, and what you can use HCl plus HCl plus HCl. Okay, so these are the reagents that you can use here. Reduction of nitro compounds. What is happening here in nitro? Oxygen is leaving and you are replacing oxygen with hydrogen. So obviously it is a reduction. You're removing oxygen and adding hydrogen. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, next is a monolysis of. Now, in this case, you have everything there. A monolysis of alkyl. Alright. अच्छा, what will be prepared? Tell me. क्या बनेगा?
Ammonia.
Ammonia. Why? Method of preparation of क्या है बताइए तो? What are we preparing?
Ammonia.
Ammonia. अरे where
Amine,
are you?
Amine.
ना amines हाँ ठीक है. Now अच्छा एक बात बताइए. If you have hydrolysis, so in hydrolysis we add water, right? Correct?
Yes,
yes or no?
Yes.
हाँ अब तो ammonolysis में क्या ऐड करेंगे? अमोनिया ऐड करेंगे, है ना? अमोनिया ऐड करेंगे. So it is very easy. We have RX plus NH3. We have seen this reaction in alkyl halide also. So what will you prepare? You will prepare RNH2 plus HX. ठीक है? So you have prepared ammonia here. Okay. Now in this, what you will have the order of reactivity. Questions can be asked on order of reactivity, and we can see that this bond is getting broken. This bond is getting broken. So if bond is weak, then the reactivity will be high. So how can be the bond weak? If you have a long bond, so Ri will be long, right? So this is the most reactive. Okay, most reactive, weak bond. Then you have RBr. You have RBr. Okay, followed by you have RCl. Followed by you have RF. Okay, followed by RF. So this is long bond and hence weak. Okay, and hence weak. So it is easily broken. So it is easily broken. Is this clear? Yes or no? Please tell me. The reaction happens like this. You have
Yes,
NH3, it attacks on R, and this bonds break. Okay, and this bond breaks. Okay, can I move on? Yes or no?
Yes, sir.
देखिए अब क्या हुआ, you have simple RX is there, and you treat this with NH3, you get RNH2. But the reaction will not stop here. If you have more NH3 present, if ammonia is there more, then oh no, it doesn't matter if there is more ammonia, there will be always some ammonia present, right, which will react with this RNH2, and then what it will prepare? A 2-degree amine, RNHR. And now if there will be some more ammonia, it will react with this and it will prepare R, N, R, and N. So this is 1-degree amine, 2-degree amine, and this is 3-degree amine. Okay. And that is why you get a mixture of product when you do ammonolysis of alkyl halide. Is that clear? Yes or no? Tell me.
Yes, sir.
Okay. Next is reduction of nitrites. This is the third method of preparation, reduction of nitrites. Now, in reduction of nitrites, you can use the reducing agent. Okay. To use a reducing agent, what are those? R, then you have C triple bond N. Okay, C triple bond N. Now, in this, you can use reagents. What reagents can you use here? The reducing reagents are LiAlH4, lithium aluminium hydride. Okay, furthermore, what you can use? H2 in the presence of nickel. This is also useful. And there is one more which you don't have to remember, which is sodium in the presence of mercury and alcohol, ETOH or C2H5OH, ethanol. Okay, so you can remember this because it is a good reducing agent, LiAlH4, and what it will do, it will reduce this nitrile to R single bond C. Now C will get what hydrogens? 2 hydrogens C will get. Okay, this will be CH2, and nitrogen will get 2 hydrogens, so this will be NH2, and you have got one amine, and you have got a amine. Is that clear? Yes or no?
Yes, sir.
Okay, now let us look at some questions. See, even if you have, let us say benzaldehyde, sorry, not benzaldehyde, nitrobenzene, and you treat this with what? H2 in the presence of PT, then also you are going to get aniline. How will you prepare aniline? This is preparation of aniline, right? NO2. Then furthermore, what you can have? Yeah, you can have things like there is a benzene group, there is C triple bond N. Now, in this, you are not going to get aniline. You will see why. You are going to get CH2, NH2. Then obviously this is not benzene, right? This is not benzene. Sorry, this is not aniline because NH2 is not directly attached on the benzene carbon. Is this clear? Two things, yes or no?
Yes, sir.
Okay. Next is
So in
reduction of
the reagent.
Reagent here.
Yeah, in second one.
H2
Same.
nickel. अभी जो किया हमने नाइट्राइल ये के साथ नाइट्राइल के साथ ना. Okay. Now,
yes,
is reduction of amines. In reduction of amines, you have R, CONH2. Here also you are going to add LiAlH4. First step will be adding LiAlH4. Second, what do we use here? Because we are reducing, and after that we need some hydrolysis, so H2O. And you will be getting product R. Now this oxygen will be leaving and you will be having CH2. Instead of one oxygen, you will have 2 hydrogens, and this NH2 will be as it is, and this NH2 will be as it is. So we are not doing anything on this nitrogen here, rather we are just converting the C double bond O to CH2. We are just converting the C double bond O to CH2. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay, so this type of question was asked previously. What is the reagent that will be used? And you have to prepare CH2NH2. Okay, so in this LiAlH4, second is H2O. These 2 reagents are used. Is this clear? Yes or no?
Yes, sir.
Okay, now very important. Okay, very important. This which one? This was fourth. Fifth one is Gabriel, Thalamide, synthesis. This is very important. This is very, very, very important. Okay, this has been asked multiple times. It has been asked multiple times. Now, in Gabriel Thalamide synthesis, Gabriel Thalamide is a very unique molecule. You have a benzene ring. Okay, that is why it is asked very much. You have a benzene ring, and there is a different way of making benzene. You can write benzene like this. Okay, don't worry where are the double bonds. And then you have an H here, C double bond O, C double bond O. You have carbon here, which is bonded to NH. Now, here we have this hydrogen here. This hydrogen is here, and we add a base. We add a base that is KOH. So obviously, this OH will attack on this hydrogen here, and it will abstract it, and you will be getting a salt. You will be getting a salt. Here there will be nitrogen. It will be bond O, double bond O. And now, since we have lost H plus, this will be negatively charged, and the K plus of KOH will be in the vicinity, in the neighborhood. Okay. Now, after that, we react this with alkyl halide. We react this with alkyl halide, that is RX. That is RX. Now, obviously, this R is what delta positive, and this X is, sorry, this is delta positive, and this is delta negative. So N negative, what will happen? It will attack on this R. It will attack on this R. And what are you going to prepare? Now, this R will be here, and this bond will be broken. And this X negative will abstract this K plus, and it will make KX. So you are going to get benzene ring is there. Everything is similar, and you have a R group here, and there is a double bond O here, and there is a double bond O here. Is this clear till here? Yes or no? Please tell me.
Yes, sir.
Okay. Now, one thing that I should remind you here. Now, this is not very important in the board examination, but still, this should be aliphatic. Okay, it can be only aliphatic. Okay, aromatic cannot break the RX bond due to partial double bond character. Now, let us look at this molecule, and we are going to break this molecule. Okay, so you have carbon double bond O, carbon double bond O. There is N, there is R group here. We are going to add water, and what water is going to do? Water is going to break these two bonds. And it is going to break, and it is going to add OH here and the H here, and again OH here. So if you have the benzene ring, this carbon atom with double bond O, and there will be OH group attached here, double bond O, and there will be OH group attached here. And as you can see, plus you will get R and H2. You'll get R and H2. Okay. Now, see, this you will get in your notes already there. Okay, this will be there in your notes already. But let us see why. Thing that you have to remember is why only aliphatic amine. Why only aliphatic amine? Question is why only aliphatic amine? Okay, so let us see. You have RNH2, and then you have the aromatic. Sorry, only aliphatic alkyl halide. No, yeah, RX alkyl halide. Sorry for that. RX here. You have benzene ring, and then you have X here. Now we know that this is a pure sigma bond. Okay, single. And this is what? This is partial double bond character. Partial double bond. And hence doesn't break easily. and hence it doesn't break easily. Okay, this is sigma, only sigma is there, only single bond is there, and that is why it can break easily. Okay, so please remember that there is a partial, this is the crux word here. Okay, जब भी आपसे पूछे only aliphatic, why? Then you have to remember aromatics have partial double bond character. That is why we don't use aromatic amine. Is that clear? Yes or no? Please tell me. Yes, Abir?
Yes, sir.
Okay, now moving on. Next is Hoffman bromamide degradation. Hoffman bromamide degradation. So Hoffman bromamide degradation. Hoffman bromide degradation. First of all, Hoffman is the name of scientist. Now bromamide. So you have, there should be some Br2, bromine should be there. There should be amide. Okay, so amide group should be there. Okay, so you should have some R, C double bond O, and NH2 group there. Okay. Now degradation. Degradation means reduction, not reduction in the sense, but there will be in product less number of carbon in product. Okay, so these three things are there. You have to remember here the reagent is what? Br2, right? The reagent is Br2. And then you have one more thing, which is the substrate. It is the amide. It is amine. Right? So you have Br2, which is reacting with CuNH2. And what is happening? There is in the product a less number of carbon atom. There is one more reagent here, that is sodium hydroxide. So you have RC double bond O, NH2 plus Br2 plus NaOH. Now, one thing is clear that you are going to get RNH2, but how are you going to get RNH2? So this is, you are going to get RNH2. What will be the byproducts here? You will get Na2CO3, sodium bicarbonate, plus NaBr you will be getting, plus you will be getting H2O, plus you will be getting H2O. Okay. Now, what happens here? What happens here? Let us say if you have C double bond O, NH2, and then here you have Br2, NaOH. Then what is going to happen? So how many carbon atoms are here? 1, 2, 3, 4. So you'll remove this, right? And just write NH2. So you'll have 1, 2, 3, and there will be NH2. Okay. So you have 1, 2, 3, and there will be NH2. So just reduce one number of carbon atom, and then you are getting this thing. Even if you have, let us say, a benzene ring, and here you are having C double bond O and NH2, and here you are adding Br2 with NaOH. Here also you are going to remove this, and you are going to get a simple aniline structure here. Simple aniline structure. Is that clear? Yes or no, please?
Yes, sir.
Okay. So these are all the methods of preparation, right? All the methods of preparation. Okay. Now, I have one question that is regarding the physical properties. Now we have questions regarding the physical properties. Now, in physical properties, one thing you have to remember, RNH2. RN, RH, RN, R and R. Okay, RN, R and R. Okay. Now you have to see that there's hydrogen bonding present, H bond present. Okay, and here H bond is present, and here no H bond due to lack of hydrogen on nitrogen. Can you see this? Yes or no, please tell me.
Yes, sir.
Okay. Also you can see that the hydrogen bonding will be greater in the 1 degree carbon, because you have 2 hydrogen atoms here, and here in the second degree, in the 2 degree amine, this is 1 degree, 2 degree, and 3 degree. 3 degree has no hydrogen bond. If I compare the 1 degree and 2 degree, then in this you can see that the 1 degree has 2 hydrogen. That is why it will be having more intermolecular attraction between 2 molecules, right? Now it does not have any hydrogen bonding. That is why it will not have any intermolecular force of attraction. And due to this reason, we can write 1 degree amine, 1 degree amine have higher boiling points. They have higher boiling points. Okay. So is this clear, yes or no?
Yes.
Okay. So there was one question asked in that they asked compare the boiling point of two compounds that were given. Was you had 3 carbons, there was NH2 group, and you had nitrogen, it had 3 individual CH3 groups attached here. Okay, so the answer was directly in 3 degree amine, there is no hydrogen on nitrogen, and hence it cannot make intermolecular hydrogen bonds. Okay, hydrogen bond, hence 1 degree amine will have higher boiling point. Okay, will have higher boiling point. Okay. Next is the basicity. Okay, next we are going to compare the basicity. Can I move? Yes or no, please tell me.
Yes.
Okay. Basicity, you have to also remember one thing regarding the basicity. How does it show basic character? So you have RNH2. If I react this with any acid, let us say HX, HCl ho gaya, HF ho gaya, HBr ho gaya, then you have this nitrogen which has lone pair, and this lone pair electron will attack on this hydrogen, and what is going to happen? This bond is going to break. And generally acid-base reaction are in equilibrium, so we'll write this equilibrium arrow, and you will see that you have R NH3. Now, since it has lost 2 electrons, it will create a positive charge here, and SX is gaining some electron, that is why it will gain a negative charge here, and you will be making a salt like this. This is the salt here of, this is the salt. Okay, so positive charge and negative charge here. Now, it is represented by what basicity? Basicity generally it is represented by Kb. Okay, represented by Kb. So if Kb is higher, then what is going to happen? The basic character will be higher. Okay, so you can write the basicity directly proportional to Kb, dissociation constant of a base. But generally Kb is in terms of, let us say 3.2 into 10 to the power minus 4 as it. So it is not a very humane term to say, right? Humans, they have more ability and they can remember things such as whole numbers, and that is why a new thing which was introduced was pKb. As we have pH now, so pKb was introduced. So pKb was introduced just to make the numbers more human, but for that the scientist has to do bit of complex calculation, that was minus log of, they have to take the minus log of, negative log of Kb. Now, as you can see that pKb is what it is, inversely proportional to the Kb, because there is a negative sign here. Okay, so you can write here that Kb, it is what, it is inversely proportional to the pKb. Okay, and then what you can write, you can also see that you have basicity that is directly proportional to Kb, and which is inversely proportional to pKb. And hence you can say that if pKb is lower, then the basicity will be higher. Okay, so basicity and pKb are inversely proportional. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay, now first comparison of basic nature will be with ammonia. Okay, so comparison of, we have alkane amine. Let me write it like this. You have RNH2 versus NH3. RNH2 versus NH3. RNH2 versus NH3. Okay, now first of all, you can see what are the two reactions. Okay, so you have RNH2 it will react with H plus. It is going to give R, N. There is hydrogen here, hydrogen here, hydrogen here. There is a positive charge here. Okay. Now, second thing that it is happening with NH3 is what? NH3 plus you have a hydrogen here, and then you have nitrogen with 4 hydrogens. It has a charge, positive charge. Okay. Now, which is going to attack more easily here? Now, in both the cases, you can see that nitrogen is forming 4 bonds, so 8 electrons is there. There is a positive charge here, which needs to be dispersed, and there are 4 substituent atoms here on nitrogen. So we can't see the product and tell which is more stable. What we have to see, which can attack fastly. So the one which has more electron density will attack fastly. As we know that R group is present here in the alkane amine, that is R group, and it is what? Plus I, right? It gives electron. Now, if it gives electron, that means the nitrogen will be having excess of electron in the lone pair, and it can easily donate the electron on the H plus. Okay, so RNH2 is higher in basic character. Okay, so RNH2 will be having highest basic character, and that is why, because of this plus I effect of R group. So you'll say RNH2 is more basic due to the RNH2 is more basic due to the plus I effect of alkyl group, which eases the donation of, lone pair electron. Other I should say not donation. Donation में तो दे के चले जाते हैं ना, sharing लिख देते हैं. Sharing of lone pair electron. Okay. Now they can ask you 2 things. Compare Kb of CS3 with the CNH2 and NH3. ठीक है. Kb क्या होता है? Directly proportional to basicity. तो कौन ज़्यादा basic है? CS3 NH2 ज़्यादा basic है. So this will be having higher Kb than NH3. But you have to take care if they just add this one small letter P. Compare pKb of CS3, NH2 and NH3. तो यह ध्यान रखिएगा आप लोग. Please remember Abir that pKb is what? pKb should be lower. pKb should be lower, and then the basic character will be higher. So you have CS3, NH2. It will have lower value of pKb than NH3 because basicity and pKb, they are inversely proportional. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. No. Next is one distinction of the basic character in aqueous phase and the aqueous phase and the gas phase when we compare the basic character of amines. Okay, comparison in between 1 degree, 2 degree. So we have 1 degree versus 2 degree versus 3 degree. So we have this comparison. So in this comparison, we have a gas phase. Okay, please remember there is a gas phase comparison when everything is there in the presence of gas. If you have in gas phase, then the order is 3 degree followed by 2 degree followed by 1 degree and then followed by ammonia, NH3. That is the last case here. Okay, NH3. This is the gas phase. Now, in terms of aqueous phase, complications happens. In terms of aqueous phase, what happens? Some types of complication happens because of C. Let me show what happens in aqueous phase. Aqueous phase, you will have this R, N, H, 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 right? This will be positive. Now this positive is there, so it will be attracting some electrons like this. If it is attracting electrons from hydrogen, this will become more positive. And what will happen? It will form a kind of hydrogen bonding with the water molecule present. So this will also form. This will also form. Can you see this? Yes or no? Please tell me. Yes or no?
Yes.
Tell me.
Yes.
Hydrogen bonding. How many hydrogen bondings are here? How many hydrogen bondings can you see?
3.
Then you have R, nitrogen, hydrogen, hydrogen. There is R group here. So there will be OH2, hydrogen bonding, OH2, hydrogen bonding. This is what? This is 2 degree. So this is 2 degree amine, and it has 2 hydrogen bonds. And if you look at the R, N, R, and there is one, there will be a positive charge here. One hydrogen here, there will be a positive charge here, and OH2 group is here. Now this has only one hydrogen bond. Okay, this has only one hydrogen bond. Now it will be, which will be more stable due to solvation. According to solvation, we have, according to solvation, 1 degree is having more attractive forces, right? So 1 degree will be more stable than 2 degree, than 3 degree. This is according to solvation. But according to electron sharing, the order is 3 degree is greater than 2 degree is greater than 1 degree. So we have a conflict of interest here. Can you see this? Yes or no? Please tell me. You understand both of these points?
Yes, sir.
Anna? So now what is going to happen? You have to remember two things. There cannot be, now it is very difficult to state a general rule here. It is very stable. It's very unstable, right? Because you have a conflict, like completely reverse order according to solvation and according to electron sharing. So you will remember two things. You will remember one example, the example that is there, which is of CS3 whole twice NH. It has higher than CS3 NH2. It has higher than CS3 whole thrice NH2, and then you have at last NH3. So the order here is 2, 1, 3, and then you have NH2. Okay, 2, 1, 3 NH2. Now please remember that nitrogen is attached to only one methyl group. Okay, one methyl group. Second is if you have ethyl group present. Okay, if you have ethyl group present, that means C2H5 is present. Okay, with nitrogen. So the highest is again of 2. Now, but it is followed by the 3 degree here, C2H5 thrice nitrogen, and the first is C2H5 NH2 followed by NH3. Here the order is 2, 3, 1. Here the order is 2, 3, 1. Okay, 2 degree, 3 degree, 1 degree. So these are the two questions that you have to remember. Okay, and they can ask you this question. You have to remember this. If you have only methyl, if there is only methyl, then 1, देखिए 2 तो दोनों में ज़्यादा है. In general, I can say that 2 will have higher than 3 degree and 1 degree. But if you have methyl attached to nitrogen, then the 1 degree will be, methyl में आप ऐसे याद कर लीजिएगा 1 carbon. ठीक है, methyl में कितना होता है 1 carbon. So 1 is greater than 3. 1 is greater than 3. ठीक है, methyl का याद कर लीजिए. और बाकी केसेस में आपको कैसे याद रखना है? The 3 degree will be higher than 1 degree. 3 degree will be higher than 1 degree. So only I can say, I can generalize things about the 2 degree. The 2 degree will be always higher, but for 1 degree and 3 degree, we have to look at the values that is present. We cannot predict here. We cannot predict here. We have to look at the values. So in meth, if you have methyl group attached, then 1 wins over 3. In rest of the cases, you can say that. In rest of the cases, you can say that the 3 wins by 1. 3 wins by 1. Okay, is this clear? Yes or no? Actually, this has been asked, okay, earlier also. I think 2012 or 13. One of these question was asked. Okay. Now, can I move on? Yes or no? Please tell me.
So how the question will be asked about this?
They can ask you like this. Compare the Kb of following. They can ask compare the pKb of following. They can also ask compare the basic nature of following. सही है? ठीक है, देखिए, let us say I am asking this for 1. Okay, first question, compare the Kb. तो Kb के लिए तो आपको करना होगा 2 degree higher than 1 degree higher than 3 degree. ठीक है, pKb में आपको उल्टा चल जाना होगा because it is inversely proportional. So 2 degree 1 डिग्री एंड 3 डिग्री है ना। पीकेबी का वैल्यू क्या होगा, 3 डिग्री का सबसे ज्यादा होगा, 2 डिग्री का सबसे कम होगा, बिकॉज इट इज मोर बेसिक। बेसिक नेचर का आपसे पूछे तो 2 1 3, ठीक है। बस ये ध्यान रखिए आप, पीकेबी इज व्हाट, इट इज इनवर्सली प्रोपोर्शनल टू द बेसिक नेचर और द केबी। बेसिक नेचर एंड केबी आर डायरेक्टली प्रोपोर्शनल, बेसिक नेचर एंड पीकेबी दे आर इनवर्सली प्रोपोर्शनल। इज दिस क्लियर, यस और नो, प्लीज टेल मी।
Yes, sir.
ठीक है, यहाँ पे ये थोड़ा सा आपको ये जरूर देख के जाइएगा एग्जाम से पहले, प्लीज देख के जाइएगा अमीन्स में इसको ना। Then you have a question regarding aryl amines and ammonia, which will be more. So next is the comparison between Ns3 versus aryl amine. So in aryl amine, we will have benzene ring, which is having a NH2 group here, and there will be a lone pair. This will be a lone pair here. Now we all know that due to resonance, this will be partial double bond, and this lone pair is what, it is delocalized. It is delocalized, right? It is delocalized, yes or no?
Yes, sir.
Anna, it is delocalized. So I will say that NH3 localized electron, localized lone pair electron, okay, localized LPE icon, right? Okay, and hence available for donation, available for sharing, I should say. I mean, donation is a bad word because ऐसा नहीं होता कि donate पे कुछ नहीं जाता. Now here this is delocalized. Here the electrons is delocalized. Delocalized lone pair electron not available for sharing. Not available for sharing. And if it is not available for sharing, then what will be the basic order? Which will be more basic, ammonia या फिर aniline? कौन ज़्यादा basic होगा? Obviously NH3 will be more basic ना, because ये आराम से donate कर दे रहा है lone pair electron को than NH2, ठीक है। So also this will be the order for KB. KB के लिए ये order होगा, basic nature के लिए भी ये order होगा। PKB की जहां बात आएगी वहां पे उल्टा हो जाएगा, NH3 NH2, okay. Is that clear, yes or no, please tell me.
Yes, sir.
Similarly, if they will ask you to compare NH3 CH3 NH2 NH2, then obviously you are going to do CH3 NH2 is highest in basic nature, followed by NH3, followed by aniline, okay, followed by aniline. Is that clear, yes or no, please tell me.
Yes, sir.
Okay. Now, if you have some molecule like this in which you have nitrogen and it has CH3 groups attached here, CH3, CH3. There is nitrogen, there is one hydrogen, and there is CH3. And then you have nitrogen and it has H2. Now, in this case, what you can see, because of the big methyl groups present, there will be some hindrance in the sharing of electron in the delocalization. Okay, so delocalization will not be effective. That is why this will be having more basic character. Okay, this is the order for KB for basic character. Okay, if you have N-dimethyl benzene amine, then it is going to be more basic because this electron pair is what? This electron pair is not delocalized efficiently because of big bulky groups here. Okay, so this is the order. And also because the CH3 groups are having plus I effect. Okay, so two reasons. Hindrance in delocalization, which makes lone pair electron available. Second point is the CH3 groups plus I effect of CH3 groups, makes sharing easy. ठीक है, इसको याद रखिएगा. Done? Can I move, Abir?
Yes sir.
बेसिक कैरेक्टर जो है ना, ये बहुत, ये दिस इज वन ऑफ द मेजर पोर्शन जिससे सवाल आते हैं अमीन्स में. ठीक है, सो वन मोर क्वेश्चन दैट यू कैन बी आस्क्ड इज रिगार्डिंग there is a nitro group here, nitrogen here. Okay, let us see, we have here carbon, CH2 NH2, and then you are comparing this with NH, and there is CH3, and then you are comparing this with NH2. Okay, now as you can see, please remember that this nitrogen here, now this nitrogen, it is not taking part in any relocalization. Please remember this. Okay, it's not taking part in any relocalization. Why? Because this is attached to a CH2 group. CH2 group is not having any kind of double bond, so it cannot share. So this is what? This is localized, and hence this will be having higher. Even though benzene group is present, से आपको लेना ही देना नहीं है. You have to see what is attached after nitrogen. Okay, so this is 1 degree amine, which is having a localized electron. This is delocalized. This is also delocalized, and here the delocalization will be a bit less because of entrance. So that is why this will be the order. Okay, पूछा गया था 2014 में. ध्यान रखिएगा ऐसे सवालों का, जहाँ पे लग रहा होगा कि NH2 आपका अटैच्ड है बेंजीन से, वो अटैच नहीं है लेकिन बेंजीन से. It's attached with the carbon atom. It is localized. Please remember this. It is localized. Is this clear, yes or no? Is this clear, yes or no? Please tell me.
Yes sir.
अभी देखिए, इसमें तो सवाल खत्म नहीं होंगे, बिकॉज you have electron donating effect भी होगा, electron withdrawing effects भी होगा, है ना. So इसमें again you will have questions such as, if you have to compare, एक जनरल हम ट्रेंड बता दे रहे हैं आपको, बस इलेक्ट्रॉन डोनेटिंग ग्रुप और विड्रॉइंग ग्रुप देखना पड़ेगा. If you have a benzene ring with an N2 group attached here, then if you have electron donating group, then this is going to be highest, right? The Kb will be highest, the basic nature. Right? This is for Kb. Followed by, if you have nothing, followed by electron withdrawing group. Okay, so this will be the order. ठीक है, इस तरह का एक सवाल पूछा गया था आपका. AB का ही ऑर्डर पूछा था. It had here CH3 group, यहाँ पे था एक NO2 ग्रुप. ठीक है, तो इनका, इन तीनों का ऑर्डर पूछा गया था. तो KB का ऑर्डर यही होगा, that CH3 will be highest. After that, if you have just aniline, and last will be if you have a nitro group attached here, which is an electron withdrawing group. Is this clear, Abir? Yes or no? Please tell me.
Yes sir.
एक और चीज आपको हम जो इम्पोर्टेंट है वो बता दे रहे हैं, that is Carbylamine reaction. Okay, this is important because it gives the test for 1 degree amine. Very important. Tests are very important. Okay, Carbylamine reaction. Now, in Carbylamine reaction, what it is first of all, you have to remember this is a test for 1 degree amine. यानी कि जो भी रिएजेंट होगा ना, whatever reagent that I'm going to use here, it will not react with 2 degree or 3 degree. ठीक है, first thing is that it gives test for 1 degree, यानी सिर्फ 1 degree will react. 2 degree and 3 degree amine don't react. ठीक है, 2 degree and 3 degree don't react. So what is the reaction? You have RNH2 1 degree amine plus you will use CH-Cl3 chloroform in the presence of KOH, and you get a very bad smelling thing that is known as alkyl isocyanate, RNC, alkyl isocyanate, okay, which is very bad smell, foul smell. Okay, foul smell. It produces KCl. Let us forget about the stoichiometry here, right? KCl plus H2O. Okay, KCl plus H2O. If you want to remember the stoichiometry, Cl is 3, KOH is also 3. ठीक है, so you will get 3 KCl and you will get 3 H2O. Okay, ऐसे याद रख लीजिएगा इसको. Cl3 है, 3 KOH, 3 KCl, and you will get 3 H2O. Now this is very foul smelling, and that is why it is a test. That is why it is a test for 1 degree alkylamines. Okay. Now this is AKA. इसका एक और नाम है. Since it is isocyanide, it is also known as isocyanide test. Isocyanide test, isocyanide test. Okay. Now, in this case, you also have to remember one more condition is that two alpha hydrogens should be present. Two alpha hydrogens should be present. Is this clear? देखिए, अगर आपके पास ऐसा कुछ मॉलिक्यूल है, if they are asking how will you distinguish, this question generally asked is asked like this question: how will you distinguish between 1 degree and 2 degree amines? So the answer is simple. Answer is carbylamine test. Carbylamine test. ठीक है, उसमें क्या लिखेगा? ऐसे लिखेगा 1 degree amines on reaction with chloroform. ठीक है, CH-Cl3 मत लिखिएगा, क्या लिखिएगा? chloroform and potassium hydroxide. ठीक है, hydroxide gives alkyl isocyanide, which is a foul smelling substance. Okay, इस तरह से आंसर को लिखिएगा. आंसर की प्रैक्टिस बहुत जरूरी है. ठीक है, सो फॉर एग्जांपल अगर आपको कोई सवाल, जो चीज आपने पढ़ी है ना, तो ये आपको प्रैक्टिस नहीं आएगा. दिस इज समथिंग दैट यू हैव टू डू. ठीक है, उसको आपको करना पड़ेगा कि क्वेश्चन आया तो उसका जवाब जब आपने लिखा तो उसको जवाब भी एक बार आप लिख के रखें. तो सवाल है तो उसका एग्जैक्ट जवाब आपको आना चाहिए. ये नहीं फिर आपको सोचना पड़े कि यहाँ पे शुड आई राइट गिव्स या आई शुड राइट फॉर्म, है ना, या आई शुड राइट यील्ड्स. ठीक है, वो सारा सोच में नहीं आना चाहिए. ठीक है, एक बार कोई सवाल मिला उसका झट से आपको जवाब आना चाहिए, बिल्कुल वर्डिंग के साथ. ठीक है, इंग्लिश में भी ज्यादा टाइम नहीं देना किसी चीज में. ओके, इसमें आपको और सवाल आ सकते हैं. हाउ विल यू डिस्टिंग्विश बिटवीन इथेन अमीन, ऐसे आपको दे देगा NH2 एंड इथेन डाइअमीन, इन दोनों के बीच में कैसे डिस्टिंग्विश करेंगे? सो यू विल बी डिस्टिंग्विशिंग बाय कार्बाइलामीन टेस्ट. एंड दे कैन आस्क यू हाउ कैन यू डिस्टिंग्विश बिटवीन एनिलीन. ठीक है, एनिलीन एंड you have N-methylamine. Have N-methylamine. So यहाँ पे क्या आपके पास? Here also you have NH2 1 degree. इसको हमने किया CH-Cl3 KOH, और फिर आपको क्या मिल गया? आपको मिल गया यहाँ पे NC. ठीक है, तो यहाँ पे भी आपके पास foul smelling. This is also foul smelling. और अदर अमीन नहीं होगा, इट्स बी एन मिथाइल एनिलीन। भाई अगर हम इसको देखें, नाइट्रोजन इज देयर एंड यू हैव हियर नाइट्रोजन एंड देयर इज वन CH3 ग्रुप। यहाँ पे CHCl3 जो होगा कोई रिएक्शन नहीं देगा, ठीक है। एक चीज को यहाँ पे आप ये कर लीजिए, ये 2 हाइड्रोजन होगा, अल्फा पढ़ा लीजिएगा, ठीक है। 2 हाइड्रोजन शुड बी प्रेजेंट कहाँ पे, इन ऑन नाइट्रोजन, ऑन नाइट्रोजन शुड बी प्रेजेंट, ठीक है। 2 हाइड्रोजन शुड बी प्रेजेंट ऑन नाइट्रोजन। Is this clear? Yes or no? Please tell me.
Yes, sir.
ठीक है, तो आपका मेन जो इंपॉर्टेंट पॉइंट है वो है इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन, ठीक है। यस, इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन। सो इन इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन आप सबसे ज्यादा ध्यान रखिएगा ब्रोमिनेशन का, okay। You will remember the bromination reaction. So in bromination reaction what happens, you have aniline which is NH2, right? And further what you have to do, you have to react this with Br2 in the presence of H2O. This is also known as bromine water. It's also known as bromine water, okay? And this is also done in the presence of pyridine. You will get a tri-substituted product, NH2. There will be Br here, Br in the para position, and Br also in this alpha position. Okay, so you are getting a tri-substitute. Now what is the name? This is 2,4,6 tribromo aniline. Okay, this is very important reaction, bromination in electrophilic aromatic substitution. They will ask you why do you get this? So you will say that due to the high activating nature, high activating, or you can write strong. So better word is strong activating nature of NH2 group. Of NH2 group, high activating nature. That is why you have a very delta positive, delta negative charge on the ortho position and the para position, and that is why it attracts the electrophile. It attracts the electrophile very easily. Is this clear? Yes or no? Please tell me.
Yes,
इसमें आप ध्यान दीजिएगा, अभी एक सवाल है जो आप ध्यान देके याद कीजिए कि हाउ कैन आई गेट अ मोनो सब्स्टिट्यूटेड प्रोडक्ट।
sir, it is NH2, right?
हाँ, NH2 होगा, ठीक है।
Sir, can you scroll to the left?
अरे ये सारी चीजें आप लोगों को पढ़ाई हुई हैं, आप तो ऐसा कर रहे हैं ना, बिल्कुल ऐसे पढ़ाई नहीं है हमने। देखिए सब कुछ पढ़ाया हुआ आप लोगों को। देखिए halogenation में देखिए bromation of aniline gives you to get a monosubstituted product we need to decrease the activating power of NH2, उसके बाद ये रिएक्शन किया जाता है, ठीक है। तो यही सारी चीजें हैं, बस ध्यान देना है आपको। You get this, yes or no? This you have
Yes.
each and every point mentioned to decrease the activating power of NH2. Acetylation is done. Okay, this is also important. This thing, how to get a monosubstituted product, is also very important. Okay, you can be asked regarding this, how to get a monosubstituted product. Okay, now there is one. I think there is one thing regarding Friedel Craft alkylation जो हमने शायद लिखाया हो आप लोगों को। ये देखिए, this is also very important. Okay, this has been asked multiple times. Anilines, they don't show Friedel Craft alkylation reaction. Why? Okay, so these reasons type of question. See, you can see that here we are having a product formation, and if there is a product formation, sorry, we have a salt formation, and this salt is what positively charged, and if it is positively charged, it is going to be strongly deactivated. And अगर deactivating होगा तो reaction will not proceed only. Okay, so deactivating nature की वजह से the reaction will not proceed. Is that clear? Yes or no? Please tell me. Yes or no?
Yes.
Okay. So these why type of questions are